I'm gonna screen share the separate display. And I'm gonna list it here. So let's give you an introduction about polar equation. What is a polar? Polar, let's start with the polar coordinates first. So what is polar coordinates? Well, let's start with what kind of coordinate system you already know. What kind of coordinate system you already know? Start with a C. Yeah, there's actually a name for it. C. What?
Coordinate planes?
No. It's called Cartesian coordinates. Have you guys heard about that? It's not. Hopefully, that's not the first time you hear this. It's Cartesian is also known as a rectangular coordinate system. So there are normal things called Cartesian. No idea how to spell it. I think this is how to spell it. I'm not sure. So Cartesian coordinate or rectangular coordinate. So that's just normal x comma y. So that's the coordinate system you already know. And you're like, okay, that's interesting. But there is another type of coordinate system that produce wonderful stuff, like limicons, like a corduroy, um, those type of graph. I'm gonna show you guys what it look like. So Desmos. So I'm going to show you the equation, not the coordinate system. I actually don't know how to do coordinate in terms of polar. But if you click here, there's actually a different grids. Do you guys see? Wait, hold on a second. Grid. Do you see this is called a polar grids? Yeah, that's unit circle. Good. Is a unit circle? Is this first time you guys seen this?
No.
No, you've seen it before, right?
I think
Which pre-cal teacher you have?
Oh, Miguel didn't. I don't know if he's in here anymore.
I heard. I heard.
I do remember something.
Yeah, I heard this is so this is called a polar system, and the polar system has a angles. I don't know if this works. I'm not sure. So let's say it's 2, comma let's just say pi over 2. No, it doesn't work. This will show up as Cartesian. So I don't know how to type in a polar coordinate in terms of decimals. There's probably a way to do it. Let me see if there's a way to do it. Yeah, I don't think there is a way to do it, but I'm not sure. So this is a polar system. Now, if you see here, it has a ring, right? And I'm gonna show you here. Okay, it has a 1, 2, 3, 4. Do you see that?
Yeah.
And that's like think about that's a radius.
Mm-hmm.
Like radius 1, radius 2, radius 3. So, and you can think of like this is also that there is an angle. So the Cartesian, the polar coordinate are slightly different. Its difference is it start with so there's a polar coordinate. The polar coordinates start with the r and theta. Or you can think of it as a radius, but it's actually called pole. Okay, so I think it's a radius, but there's also negative r. It doesn't mean like there's a negative radius, it's the opposite directions. Okay, so this is actually correct name is called pole, and pole is the distance from the pole. Okay, so or distance to origin. I think this is probably better. Distance to origin. Okay, so but the only thing that is really different than before, you can have a negative r. So you can have a -2 for r. That just means the opposite direction. So that's something that you guys have to see. And this one, I'm going to call it direction angle. Okay, so which direction angle that we're going to do? Now, what you're going to look is always look at the angle first. Look angle first. Look at angle first.
So theta will be in degrees, or will it be in like pi over 2?
Very good. In terms of calculus, it's always in radians. So radian only. Now, in pre-calculus, you can have 300 degrees or 30 degrees, but in calculus, we're going to stick with radians. We're not going to deal with degrees because radian is actually a better measurement of angle rather than things like that. Confusing or okay or okay? So technically, I can do a let's say it's 3 and let's say it's pi over 4. So what does that mean? That means I'm going to show you a polar coordinates here, and I happen to did that in my pre-calc class. So if I have a 3, what do we say? 3 what? 3 pi over 4. So first of all, I'm going to go to pi over 4. So again, look at the angle here. Yeah. This is pi over 4. So 3 is going to be just means this. So 1, 2, 3, and that's a new coordinate. Is that okay? Not too hard, right? So this coordinate is going to represent 3 comma pi over 4. But the thing is that there's multiple ways to represent the same coordinates. One easy way is adding 2 pi. Does that make sense? It's going to be 9 pi over 4 because you're going back around circles. That's how unit circle work. So they can represent the same thing through different polar coordinate can represent same exact location. Now, what is the weird one is you can choose to add 360 degree, which is choose to add 2 pi, but you can also choose to adding half of it. So which is adding pi to it. So this 3 comma pi over 4 can have, what happens if you're adding pi?
Wouldn't it be
5 pi over 4, right?
Yeah.
But this can change to -3. Because can I go to 5 pi over 4, which is right here, right? Now, instead of going this way, instead of going to 1, 2, 3, I'm going to go to opposite direction. 1, 2, 3, go backwards. So this one can represent another coordinate. It's the exact same thing. So instead of adding 360 degrees or subtract 360 degrees or multiple 360 degrees or multiple 2 pi and just keep the same r, I can change it to -r and just adding half a circle. Does that make sense?
Mm-hmm.
Does that make sense or no?
Yeah.
Okay, so I'm gonna give you a location. Let's say Matthias, right? And let's say Matthias and Jonathan here. And you guys have to find out the things about them. So I'm gonna say Matthias right here. Matthias is right here. So M-A-T. I don't know how to spell the rest of them.
T-I-A-S.
Okay. So can you give me one is a positive r coordinate and one is negative r coordinate. And there are infinite amount of coordinate represents Matthias. But I just want you to give me two. I just want you to give me two different coordinate represents for Matthias.
So 2r coordinates.
Yeah, two r's. One is positive r, one's negative r.
2 and negative 2.
No.
Or wait.
I think you have to look at this and you have to tell me which coordinate are you.
Oh, which one is there?
Yes.
I would be okay. So I could be 5, right?
Mm-hmm.
And I could also be negative 5. I could be...
Okay, but yeah, but give me a direction angle. So which angle are you in?
Oh shoot! Oh right. Would that be 11 times? Or...
You are absolutely right. Good job. So that's a 5, 11, 5, 6.
Wait, so then what's the line right?
I don't know if that's
What's the line right after?
It's not in the middle.
And, oh wait, shouldn't that be pi over 5? 9 pi over 5? Or no?
I don't know. It's
I mean,
not
because
exactly in the
it
middle.
looks like it has the 3 pi over 2, then it goes. I don't know what I'm talking.
And then-
about.
You don't know what you're talking about.
I really don't. But what about the 9?
But each grid is 15 degrees. If you want to help you, is each thing, each increment is a 15 degrees. So on the unit circle does not have this places. It has this one, it has this one, it has this one. This one's 30 degrees, this one's 45 degrees, this one's 60 degrees, or this one's a pi over 6, this one's pi over 4, this one's pi over 3. So it has those 3, but doesn't have the one that goes axes.
But what are the other?
And then
That's
the
what
other
pi
pi
over
What are
12
the other
is
things?
for
That would be pi over what?
pi over 12.
Pi over 12, yeah. So each one is pi over 12. So,
Except that-
but the one that I'm giving Matthias is based on unit circle. So everything I give to you is probably going to be in terms of unit circle.
Okay.
It's not going to give you anything that's pi
So
over
we don't
12.
have to worry about the other 2.
You don't have to worry about pi over 12 or
It's
I
on
don't know.
minus pi over 6 line.
what?
It's not on 11 pi over 6. It's on minus pi over 6.
Yes, you can represent that. So you can also represent this is a 5 negative pi over 6. You can represent same exact thing, yes. No. Good question to skip. Christmas tree. Try your luck. Huh? Yeah, that's what we're doing right now.
What's my strategy for this page?
No, don't care.
Pretty great.
Okay, so 5 and negative pi over 6. Now, can you give me another coordinate represents same as Matthias, but it's negative r? Yes,
negative 5 pi or 5 pi over 6.
5 pi over 6. Perfect. Does that make sense? Because I can go back 180 degrees, which is if I have 11 pi over 6, I can go backward pi, subtract pi, which is subtract 6 pi over 6. If I subtract 6 pi over 6, it's going to be 5 pi over 6. Then I can have a negative r. I can have a negative r happen. So this is a good thing. Is anybody confusing? You want to try one more?
Yes.
Okay, try one more. So Connor's here. So Connor's brand new. So Connor, I'm going to give you an easy coordinate to think about. Okay, so let's just kind of give you a breakdown. First of all, you learn about a long time ago for the past 12 years, we learned something called Cartesian coordinate, which is based on x and y. But from now on, for at least this section goes, we learn something called polar coordinate. A polar coordinate is going to be represent as the distance away from pole, which is represents r, and there's a theta right here, which is the angle direction I'm going to go. I think you have done this before.
Yeah.
If you have, yeah, you have?
Yeah.
Okay, so I'm going to give you a new coordinate. I'm going to represent this as a corner. A corner is going to be right here. I'm going to write down, I'm going to use blue.
And is the full circle still 2 pi?
The full circle is still 2 pi, yes. And each of those things. So I'm going to give you an easy one so you can determine. So this is a corner. So most of you guys need to write it down. What will be a corner's coordinate system, right? A polar system, polar coordinate app. So this one's actually a very easy one, so it's not very hard. So you guys can figure out how this works.
How would that be? Where are we starting to? Okay, now we get to.
Yes, it's really just one.
Wait, then how is that pi over 4? Pi over 4 is on the top. That's
No.
that's on the top.
4 should be over 4. It's 5.
Oh, 5.
Yes.
So Tyler, did you get Connor's coordinate?
Uh, 6, 5 pi over 4.
6 comma 5 pi over 4. Good.
How do we know if it's negative?
What'd you say? Apologies. Sorry.
How do you know if it's positive or negative? Like in this case, it's on the opposite side, but it's still positive.
I can always choose a positive R first, and that's the easiest one to think of, but because that just you don't have to go reverse direction. So it can be -6, but then your direction angle is going to be completely different. It's going to be either subtract 180 degrees or adding 180 degrees. So or adding pi or subtracting pi. So this one's 6 and 5 pi over 4. Does everybody understand this first coordinate? Okay. So this is called a polar coordinate, and also can be represented in terms of -6. What if it's -6? Where would that be?
Pi over 4.
Every pi over 4. Or could be 9 pi over 4, right?
If you add.
If you add 2 pi from there, it's fine. So if you want a negative R, you can adding pi or subtracting pi or odd pi's. That's a way to think about it. Add odd pi or subtract odd pi's. If you want a positive R, then you're just gonna add and subtract even pi's. Does that make sense?
Like 2 pi.
Yeah, 2 pi's, 4 pi's, 6 pi, and 10 pi's. Yes.
Could you have a negative pi?
You can be negative pi. Yeah. You can have negative 2 pi. It just go in different rotations. So you can add negative odd pi's or subtract odd pi's or subtract even pi. Depends on what your R need to be. So the first coordinate I usually just represent normal positions, which is the positive R and path between 0 to 2 pi. Then the next one, you can generate more and more and more. Done?
Yep.
Okay. So this is called a polar coordinate. Now, the next thing we're going to teach you is, we already teach you the coordinate system works. Now we're going to teach you how does a way to convert from polar to rectangular. There was a way to convert from polar to rectangular. You just had to think about it. If it's a polar to rectangular, there was a 2 formats. So polar to rectangular is easier. So let me go back. Okay. So polar to rectangular. And how do you change in from rectangular to polar? Now this is a conversion. How do you convert from one coordinate to the other coordinate? It turns out you already know this, but you just don't know it. Actually, x is equal to r cosine theta. Y is equal to r sine theta. And we're gonna explain how this works because this actually makes sense. Rectangular to polar is more complex, which is using tangent theta, use y over x, and using Pythagorean identity, x squared plus y squared equal to r squared. So you already know this. Also, why you already know this? I'm going to give you a perfect example. For example, I have a coordinate 2, 2.
That says y over x, right?
Yeah.
And that's equal to r squared?
Yeah, r squared. Yeah. And this is a y. Okay, so this is 2, this is 2. So this coordinate is 2, 2. I'm going to show you how to do the harder one, how to change a rectangular to polar. So 2, 2, But I'm gonna draw a right triangle. This is a right triangle here. And there's a theta here. There's a theta there. And you say, okay, well, we have to figure out what is it first. So so we got a 2, 2. And we say, hey, there is a x value and there is a y value and there's r value. Does that make sense?
Yeah.
So can I use this to figure out my angle, which is tangent of theta is equal to 2 over 2, which is tangent theta is equal to 1. When does that happen? Pi over 4. Are we okay here?
Yep.
Okay, so can I figure out 2 squared plus 2 squared equal to r squared? So r squared is equal to 8 and r equal to 2 over 2 plus minus. Well, why is plus minus important? Because you can have positive minus r, right? It really depends on what you think is. So r equal to 2 plus minus 2. So the best coordinate here is going to be pi over 4. No, sorry, 2 square root 2 and pi over 4. So this, the same thing is equivalent to 2 comma 2. It's just a much more interesting coordinate system. And of course, you can change into, let's just say it's 5 pi over 4 and negative 2 square root 2. So that it can change to, let's say, negative 2 square root 2 and 5 pi over 4. It's the same coordinate system, but you know, that's that. So we got this new coordinate system, right? We say, hey, can you convert back to rectangular? I'll convert to rectangular. So basically, I'm going to use this. I'm going to write down this side. We're going to say, okay, well, we have 2 square root 2 comma pi over 4. And all we got to do is convert that. But it turns out you already know this. Why you already know this? Because is that the same as cosine theta equal to x over r, which is adjacent over hypotenuse? And is that same thing as sine theta equal to y over r, which is opposite over hypotenuse? The same thing. So you already know this formula. You don't have to extra memorize it because x equal to r cosine theta, y equal to r sine theta. It's coming from SOHCAHTOA. Does that make sense?
Mm-hmm.
Can I just use that and see if I can convert back to 2 over 2? So that just says x equal to r cosine theta. So that's going to be 2 square root 2 times cosine of pi over 4. That's equal to 2 square root 2 times square root 2 over 2, right?
Mm-hmm.
So 2 cancel out. The square root 2 times square root 2 is 2. Y equal to r sine theta is 2 square root 2 times sine of pi over 4. So that's equal to 2 square root 2 times square root 2 over 2. And 2 cancel out. That's 2. Which is back to 2 comma 2.
So this whole unit's trick.
Huh?
This whole unit's trick.
Yeah, it's trick, it's breakout.
Doesn't seem super.
So this is rectangular to polar. So what I'm going to do is ask you to convert one. I'm going to ask you to convert from rectangular to polar and use the same coordinate, convert back from polar to rectangular. Okay, so the coordinate I'm going to give it to you is -1 and -1 and the square root of 3. I want you to change it to polar first and change it back to polar, back to rectangular.
So this isn't rectangular right now?
This is in rectangle. This is in the rectangular right now, yes. If it's a polar, then you will have angle, either in degree or radian, but mostly like degrees, radians, sorry. You can look at the work here to help you. And you can help out each other as well.
Are those definitions at the top switched? Wouldn't the first one be rectangle to polar?
No,
Yeah.
that's polar. That's definitely rectangle.
Yeah, polar to rectangular. Yeah, that's right.
Oh, wait.
Because the polar, you need to find an angle. That's why you use tangent. Find angles. And you had to know what quadrant are you into, so to determine what's the proper angles to. Because in this case, it's a -1 square root of 3, and that has to be that quadrant. Your data has to be fit to that quadrant as well. So, does that make sense?
Mhm. And then you want us to take whatever we get for the polar and convert it back to rectangular?
So once you convert to polar, you can convert back. You should get some exact coordinate ideally. You just convert from one to the other one and one back to the other one. How much time I have? What? Okay, let me just convert right back very quickly. So tangent of data is equal to what? Square root 3 over -1, right? The tangent data has to be equal to negative square root 3. It has to be at second quadrant, so the data has to improper fit in that situations. So that's going to be 2 pi over 3. Does that make sense?
Yep.
And then you can do Pythagorean identity. R's end up to be 2. So it's actually 2 comma 2 pi over 3. You can convert back using the exact same thing. It's going to be same thing. Yeah, I mean, you can do the rest. Niasha, keep on working, and Bobby, keep on working. Get 10 more minutes to work through. And after 10 minutes, I'll write you down.